welcome to the AI4Copernicus first round of café series. Let's welcome our first presenter, Richard. Hello, Richard.
Hello.
Richard is a principal engineer at Equinor. Equinor is one of the largest European companies in the energy sector with more than 21,000 employees. Richard will tell us more on that. We are very pleased to have all of you today with us. And our plan is to have these short sessions in order to be able to communicate and interact with you, share our views and listen to your opinions. Our plan for today's presentation is to have a short 10-15 minute presentation. All views are personal views that our presenter has. And let's start with Richard. So Richard, the floor is yours.
Thank you, Xenia. And hello, everyone. So just to repeat what Xenia was saying, this is being recorded. No confidential information will be shared. So no secrets today about Equinor. And this is really about, and the purpose of this is to inspire you to apply for AI4Copernicus funding. So I actually don't have any answers. I have a question. I have lots of questions for you, and hopefully you'll give me some answers. So let's go. How can Copernicus data support a high value, low carbon, safe society? So my name is Richard Hall. I'm Equinor's expert on satellite data, and my job is to get the most out of satellite data for Equinor. And in AI4Copernicus, which is a really wonderful consortium from all over Europe, I'm responsible for generating the energy user stories. Where can we build energy? Where is the demand for energy? How can we improve renewable energy efficiency? And those user stories are not just Equinor. They can be the EU, they can be national governments, cities, companies, or individuals like yourself. But as I work for Equinor, as I'm work for an energy company, safety is always first and foremost. A known situation is a safe situation. This allows us to be proactive rather than reactive. Both society and authorities are like this. If we know and understand the situation, we make better decisions to optimize our operations, to make our daily life. And if we have confident, safe, and efficient operations, it increases our reputation and it increases investor confidence. So what is AI4Copernicus? Well, we want to bridge the gap between research to commercial resources and building this bridge across the valley of death. This is where a lot of great ideas don't succeed because they couldn't find the way to the users. So understanding who your user is important, and the user understanding what you're presenting is also important. Because in Equinor, we know that data can provide you with an extreme amount of answers if you ask the right questions. And in satellite world, we are facing an increasing amount of data. And yes, there is data in 2010, you just can't see it. But not only is there an increasing amount of data, there's an increasing amount of users, such as yourselves. And it's increasing at an exponential rate. So there's data everywhere. If you know the rhyme of the ancient mariner, there's water, water everywhere, not a drop to drink. When it comes to data, we have to be able to use it. So that the collecting data is easier today. But making sense of that avalanche of data is where the challenge comes. And we know that we can digitalize the workflows in programs like AI for EU, in AI for Copernicus, and we can integrate those multiple observations into a summary, we can find solutions. And we can take advantage of all this data. I mean, the Sentinel satellites collect 10 terabytes of data a day now. That was unheard of 20 years ago. But we don't actually want data. We want information. And decision makers, whether it's an individual or a company or a government, they should be focusing on the accuracy and quality of the information and not the source of data. The weather forecast is a good example. 90% of a weather forecast is satellite data. But all we're interested in is the icon and the accuracy of the icon. As you can see for Stavanger, where I'm sitting, the weather forecast in Norway are quite confident that it's going to be actually good weather. This is the first time I've seen this forecast this year. It's really good to be having good weather. But they tell us with their green and amber and red confidence levels how accurate they think they're going to be. And that allows us to make good, confident decisions. I don't need to take my rain jacket this week. And we want to take this concept and apply the approach to a weather forecast to all the other satellite data, because we want analysts to analyze. If you all, I'm going to promote you all to brain surgeons. And you have 1,000 MRI scans in front of you. Which 10 do you look at? Which 5 do you look at? Do you take the first 10, the last 10, a random selection? Or do we use machine learning and artificial intelligence to tell you these are the 10 scans with the most anomalies? Please you apply your knowledge and expertise to these 10 scans. We maximize your time. So back to those energy user stories. Where can energy installations be built? Where will there be energy demand? And how to improve that the renewable energy production? Because what we want to do in Equinor and in society, our goal is to produce high value energy with a low carbon footprint safely. But that's also where you want to live. We all want to live where there's in a safe, high value society with a low carbon footprint. And we're going to be living in smart cities in the future. By 2050, 68% of the world's population will be in urban centers. Smart cities will need energy. But how much energy? Smart city inhabitants will want reliable, low carbon energy mix to live in their smart city. Where will it come from? And to find these answers, we need to find the user stories, and we need to change the conversation. Because this is what happens when you're innovating and have ideas. You start with, we get stuck in this traditional customer supplier table tennis dialogue, which goes backwards and forwards. What do you want us to do? What can you do? And you go, we need to change this and become more brainstorming, collaboration, which is why we're having this cafe. This is my challenge. Does this address your challenge? And we just don't want information. A fantastic example of using satellite data is that the Norwegian government is making planet satellite data available to monitor tropical rainforests. But in the beginning, that actually is just supplying bad news where the trees have been cut down. Can we use artificial intelligence, machine learning processes to know what to do, which is to plant, know what trees to plant to maximize carbon sequestration. That's much better information. We can actually do something positive. Where can energy installations be built? Where will there be energy demand? And how to improve renewable energy production efficiency? These are the user stories around energy. As I said, I keep repeating this, it's not just Equinor, it's everybody, from the EU to the individual. So what examples can we look at? Wind farms. This is the World Atlas from the World Bank of wind farms. Where can we build wind? They also have the Solar Atlas. And I want to concentrate on this as an example because it can be used in different ways for different parts of society. Because not only does that data tell us where to build solar farms or where we can build solar farms. This startup, Ajuma from Germany, took the same data and created a safety app to tell you how long you've been in the sun. So you can either go inside or put on sun cream, because the app your phone knows where you are. It knows the weather forecast. It has the sensor detecting the solar radiation. So that same data can be used by an industry or by an individual to make good decisions. Taking another example, Alan Turing Institute in the UK, they're running this project, solar nowcasting with machine vision. Because today we don't actually know how much solar energy is being pumped into the UK's electricity grid at any given time. It's a little bit of an unknown. So by using artificial intelligence, they're hoping to, and open source data, where are the solar farms, and more accurate weather forecasting, they'll be able to make better predictions. And if you can make better predictions on solar energy or wind energy for that matter, you can actually reduce the demand for more conventional energy today. Some more inspiration. I think another success story from 2020, despite everything that's happened was COVID, was the RACE dashboard, the Rapid Action and kind of Coronavirus for EO dashboard that the European Space Agency, the Japanese, and NASA have built. One of my favorite examples is using satellite data to monitor traffic, and not just traffic, but traffic speed. How can this data be used to understand energy demand and energy supply? So going a little bit deeper, when we say, where can I build energy? But how many and where solar farms and wind farms can be built in Europe? How much energy does a settlement use? Can we use satellite data to plan the cleaning of solar panels on these huge solar farms? Because in a dust storm that hits a solar farm, it may only affect one corner of the field. So coming to the end, how can we help you? Why are you listening? What are your ideas? But also, what do you need? So when we start running these projects, the proposals are going to need data input. You know, for example, every machine learning example needs a labeled data set. So what are the requirements? What have we missed? What are the new ideas? How can we help you complete the proposal and the projects? So thank you. And this is just a quick summary of all the partners in AI for Copernicus. What I'm wanting to hear from you is, your inspiration, your ideas, and your questions. Thank you very much so far.
Thank you very much, Richard. Thank you for the inspiration. I think you did provide us with lots of inspiration, and I think our participants will agree with me. Just to say a few words about the AI4Copernicus project, which is, you can leave this slide. Yeah, that is great. As I was saying, the AI4Copernicus project is an EU-funded project that aims in a way to bridge the different communities, the artificial intelligence community with the Earth observation community, and make AI4EU the flagship project and platform, the platform of choice for users of Copernicus data, and artificial intelligence users, researchers, industry, academia, and government officials, and citizens, why not? As part of the AI4Copernicus, we also have open calls targeting citizens. So as Richard was saying, for the first round of our open calls for use cases, that is small consortia projects, up to 3 partners, where at least partners should be a low technology company. We focus on 4 industrial domains. One is energy, the others are agriculture, health, and security. So our series of webinars will be initially targeting these 4 industrial domains.